The history of math is our intellectual foundation for understanding science. Science. Beautiful, awesome, wonderful science. It's the creative foundation for our ineffable future. Hi, I'm Gabrielle Burchak, and this is my podcast, Math, Science, History. Hey friends! Do you have a great idea for a new podcast? If you're thinking about starting a podcast, I highly recommend using Libsyn to help you plan, launch, and grow your own podcast. Math Science History has been on Libsyn for almost 3 years, and we love it. We really do. Going with Libsyn is one of the best decisions we've ever made. They have everything you need to plan, launch, and grow your own podcast, including fantastic resources created by experienced podcasters who show you what equipment works best, how to record great audio, and how to get your show on various popular platforms like Apple, Pandora, iHeart, and more. As my friend, when you sign up, you get your first month of podcast hosting for free. They have various prices depending on your budget, too. This is the time to start podcasting. Visit Libsyn.com and use code FRIEND, F-R-I-E-N-D. That's Libsyn.com. Use code FRIEND, F-R-I-E-N-D, and start creating your awesome podcast. Once upon a time, there was a woman named Gabrielle. She had 3 older brothers and a sister named Michelle. Gabrielle loved math and science. Her father encouraged her to study mathematics, even though her mother was kind of indifferent. She loved to dance, sing opera, and was also an actress. As a teenager, she learned how to gamble. Even though everything I just stated is absolutely and positively true about my life, including my sister's name, the opera, the math, and the acting, this story is not about me. This story is about Gabrielle Emilie le Tonnelier Débouté Marquis du Chatelet, also known as Emilie du Chatelet. Du Chatelet was born in Paris, France on December 17th, 1706. Her mother was Gabrielle Anne du Frolet, Baron de Boutet, and her father was Louis-Nicolas le Tonnelier de Boutet, who was the principal secretary to King Louis XIV. The king always found favor with her father because they both had reputations of seeking the company of other women. Her early education is speculative. What can be known about her education comes from resources that describe what education would be like for a young girl of high status. She possibly studied alongside her younger brother, who was educated at home. Her father would hire tutors for her, and by age 12, she was receiving an education in literature, math, and science. Du Chatelet was fluent in German, Greek, Italian, and Latin. An inventory of her father's books shows writings by poets Jean de La Fontaine and Paul Scarron, as well as Euclid and René Descartes. Further inventory of her father's property shows that she had access to billiards, cards, board games, fencing gear, and horses for riding. She was musically gifted and could play the harpsichord, sing opera, and dance. No doubt, Du Chatelet received a well-rounded education and had a broad interest in many things. But her expected role in life was not to utilize those skills. As the Baron's daughter, she was beholden to a suitor named Florent Claude Marquis du Chatelet Lomont. Lomont was 12 years older than her. For her family, he was a necessary fixture in their lives because he would be able to solidify their connections to royalty. Hence, her marriage would be a business deal. Though her father had elite status, it was not an ancestral status. Instead, her father had worked his way up in the royal service, earning his position among the king's staff. Her father, de Boutet, represented the lesser nobility, who had risen to elite status through service to the crown. Alternatively, her suitor would come from an ancient lineage of European royalty, all for the dowry price of 150 livres. In US dollars, in today's economy, that would equate to a little less than $11 million. Thus, for $11 million, her husband was made the governor of Semur-en-Auxois in the French kingdom of Burgundy. Though they spent time in Paris between 1726 and 1733, Du Chatelet and her husband lived in Semur-en-Auxois, where she gave birth to 3 children. Sadly, around 1734, her son, Francois Victor, who was only 1 year old, died. She knew that her marriage would not be that of romance or idealism. Instead, as she wrote in her translation of Mandeville's fable, that she proceeded in the, quote, propagation of the species. After her third child was born, she moved back to Paris. In letters to friends, she wrote that she wanted to continue her previous activities with promenades, visits to the theater and opera, as well as evenings, dining, and drinking with friends. However, she also had other plans. She had found interest in the mathematician Pierre-Louis Moreau de Maupertuis. Thus, during her time in France, she also began to focus on advanced geometry, algebra, and the physics of Isaac Newton. She became so immersed in this identity that for many of the paintings that she commissioned, she is seen with a book or a protractor. No doubt, du Chatelet made it known that her true passion was mathematics. The mathematics that she learned from Maupertuis reflected the education that he received. He was a prominent academic and was elected to the French Academy and France's Academy of Science, of which he would become the leader of the daily gatherings. He often attended the cafes in Paris and traveled within the social circles of Newtonian academics. Several years before Maupertuis met du Chatelet, he traveled to the University of Basel in Switzerland, where he learned from Johann Bernoulli, one of the earliest contributors to the development of calculus. So, when Maupertuis met du Chatelet, he was well-versed in algebra, geometry, and calculus. He encouraged her to read mathematical works from authors that included Nicolas Guinet and Guillaume de l'Hôpital, one of the early founders of differential calculus. Still, her part-time instructor, Maupertuis, was not enough for du Chatelet. She would often write him in an effort to engage in intellectual discourse. In January 1734, she wrote him asking if he could give her some mathematical problems to work on to continue her studies. He often did not respond as urgently as she wanted. So, while at a wedding in April 1734, she wrote a letter to him stating, quote, "It is not for me that I wish to become a mathematician. It is out of my respect for you," unquote. However, shortly after that, she sought out the mathematical expertise of Maupertuis' protégé, Alexis Claude Clairaut. During this time, Clairaut also began to tutor François-Marie Arouet, who went by the pen name Voltaire. It was in 1733 that du Chatelet met Voltaire. Shortly after meeting her, he had told a friend that he had never seen such an incredible creature before. Likewise, in December 1733, she had also written to a friend about how Voltaire charmed her. Even though she was attracted to Voltaire and eventually engaged in a long-lasting, intimate relationship with him while she was married, she also had other lovers. This was commonplace in France. However, at times her love life became the subject of public scrutiny, which did not serve her well, even today, as she is often referred to as Voltaire's lover. By 1735, du Chatelet began to commit more of her time in Champagne, France, and Brussels, which at that time was part of the region of Austria, Netherlands. Her relationship with Voltaire flourished, and she found great encouragement and support from her lover. During this time, she began to define herself as a thinking creature. Furthermore, her husband, Lamont, equally embraced Voltaire as her lover. He had no problems accepting that he was her muse. And he fully accepted that Voltaire was part of the, quote, expanded household. Furthermore, her husband and Voltaire had become trusted friends, as Lamont often helped him develop his works. Before I continue with the story on du Chatelet and her relationship with Voltaire, I would like to ask if you could please give a listen to today's sponsor. Without these sponsors, the funding for this podcast would not be possible. Everybody wants more energy. Even when you exercise and take care of your body, sometimes that energy still isn't there. If you can relate, consider Athletic Greens. Whether you eat keto, paleo, vegan, dairy-free, or gluten-free foods, Athletic Greens, also known as AG1, is a product that you can drink every day. It helps give you more energy, helps with your gut health, and it optimizes your immune system. AG1 gives you 75 high-quality vitamins, minerals, probiotics, and adaptogens. For less than $3 a day, you can reclaim your your health. What I really like about AG1 is that for every purchase, they donate to organizations to help feed kids in need. Also, Athletic Greens will send you a free 1-year supply of immune-supporting vitamin D and 5 free travel packs with your first purchase. Just visit athleticgreens.com/emerging. That is EMERGING. Again, that is athleticgreens.com/emerging to take ownership over your health and obtain the ultimate daily nutrition insurance. Voltaire and du Chatelet carried on with great intellectual and scientific discourse. They set up a laboratory in her home and began to run experiments with fire. Interestingly, Voltaire wanted to disprove the theory that fire is a material substance. Du Chatelet also sought to disprove the same theory. However, she disagreed with Voltaire's theories. Thus, they both immersed themselves in the research of fire. By 1737, she was engaged in a friendly competition with Voltaire on the properties of fire. This became the topic of an essay she submitted anonymously to the Paris Academy of Sciences for the 1738 science competition. Voltaire also submitted his essay for the same competition. However, neither one of them won. Even so, both of their papers were published along with the top 3 winners of the competition. The first place went to the brilliant Swiss mathematician and physicist Leonhard Euler. Thus, in 1738, her first published paper, titled Essay on the Nature and Spread of Fire, made her the first woman to have a scientific paper published by the Academy. What is most exciting about this paper is that in Chapter 4, du Chatelet writes about the research that she conducted on assorted colors of light. What she found was that different colors of light had their own distinct heating power. Thus, du Chatelet foresaw a behavior that we now refer to as infrared radiation. She predicted this discovery even before it was discovered. She was indeed a brilliant woman. If you are interested in reading some of her works, I will supply a link to a website called Project Vox in my podcast notes and on my website at mathsciencehistory.com. Project Vox is a phenomenal research-based website that provides a variety of philosophical works from individuals in history who were marginalized and intentionally eliminated from the male-centric philosophical canon. So if you have time, I highly recommend nosing around on this website. For the record, this is not a sponsored ad. I just really like this website. In 1736, Voltaire began working on his book titled The Elements of the Philosophy of Newton. Du Chatelet had been helping him with this book. Inspired by Voltaire, she also began writing a treatise on Newtonian physics. In 1740, du Chatelet anonymously published her treatise, Foundations of Physics. It was her intention to create a work that explained Newton's philosophical system. However, Foundations of Physics was not only a reflection of Newton's work, but also of the eminent mathematician, physicist, and polymath Gottfried Wilhelm Leibniz. It was a unique move on her part because, in philosophical circles, scientists were debating the differences between the physics of Newton and the metaphysics of Leibniz. Alternatively, du Chatelet's Foundations of Physics surpassed the debate and brilliantly highlighted the merging of 2 theories within one body of work. By doing this, she created a precedent that validated the philosophies that Immanuel Kant embraced. The Foundations of Physics far surpassed Voltaire's work in detail and knowledge. This is probably because of her extensive mathematical capabilities. Her work looked at the laws of nature, the mechanics of Newtonian physics, and the findings of Galileo Galilei. This work also addressed theories on space, time, and matter. Foundations of Physics also detailed gravity's effect on free-falling objects, the pendulum, and the orbits of our planets. But what makes her treatise so unique is that she also included theories on metaphysics as she addressed the principles of reasoning concerning the knowledge of God. Within 2 years of publication, this work had been copied, translated into multiple languages, and distributed beyond Europe's borders. Another unique and groundbreaking distinction that came out of du Chatelet's Foundations of Physics was her argument in favor of Leibniz's theory that a body's force equals the body's mass times the square of the velocities. Leibniz had stated that the formula for force was F equals mv squared, that he referred to as vis viva, which translates into a living force. While presenting this argument, du Chatelet condemned the prior work of the renowned French mathematician Jean-Jacques Ditoit de Mairan, who argued in favor of René Descartes' theory that vis viva was equal to mass times velocity, stating that the formula was F equals mv instead of F equals mv squared. Leibniz's description of vis viva was the early expression of the conservation of energy that we now refer to as kinetic energy. The formula for kinetic energy is Ke equals 1/2 mv squared. However, de Mairan's description of vis viva, as argued by Newton and Descartes, described force as a conservation of momentum. In other words, de Mairan, Newton, and Descartes argued that the momentum of force is conserved and that force is equal to the object's mass times the object's velocity. Today, this equation defines momentum and is written as P equals mv. Thus, de Mairan was not happy that du Chatelet had condemned his work and set out to defend his work and diminish her intellect. At this point, it was 1741, and the author of Foundations of Physics was still considered anonymous, even though some knew that the author was du Chatelet. Thus, the vis viva debate ensued. However, his actions backfired. By calling her out, de Mairan put du Chatelet on the same platform as other renowned mathematicians of her time and validated her intellectual status within the male-centric math community. Furthermore, du Chatelet replied to de Mairan's defense. Using her exceptional mathematical skills, she refuted each of his points and further supported her stance on the definition of vis viva. In 1742, she published a second edition of Foundations of Physics. This edition was printed under her name and included her vis viva debate with de Mairan. This edition was translated into German and Italian. In Italy, the Italian translation of Foundations of Physics was used by Laura Bassi, the first female to become the highest paid professor in Europe. In 1746, du Chatelet was elected to the Bologna Academy of Sciences. Du Chatelet also wrote a French translation and commentary on Isaac Newton's mathematical principles of natural philosophy, which at that time was the foundation for understanding the fundamental laws of physics. However, in 1749, her health declined rapidly within 6 days after giving birth to her fourth child. She had difficulty breathing and a violent headache, as one of her physicians had noted. She resigned to bed rest and, in the process, developed a blood clot within her pelvis or legs. As the blood clot broke up, it traveled throughout her body to her heart and lungs. Sadly, on September 10, 1749, the 42-year-old du Chatelet died of pulmonary embolism. Du Chatelet died before she had the chance to release her French translation of Mathematical Principles of Natural Philosophy. However, her translation was published posthumously in 1756 and became France's standard work on physics. Also, after her death, Denis Diderot and Jean-Léron de Lambert wrote about her philosophies, mathematics, and scientific writings in their work known as Encyclopédie. So even though many know Gabrielle Emilie le Tonnelier de Boutet, Marquis du Chatelet, as the woman in Voltaire's life, she was much more than his lover. She was a gifted and accomplished mathematician. She alluded to infrared radiation. She set the foundations for a philosophy that validated Kant's idealism, and through her dispute with de Mairan, she established herself as a prominent female mathematician in a male-centric world. She was fearless, outspoken, and devoted herself wholeheartedly to studying math and science. She knew she would encounter opposition by the mere fact that she was a woman, and that didn't faze her. She knew that her intellect would be her most outstanding defense, and she was not afraid to use her knowledge as her greatest weapon. Du Chatelet was also a woman who inspired other women and continues to do so with her tremendous and accomplished legacy. Thank you for listening to Math, Science, History. If you enjoyed this, please remember to leave a review. I would really appreciate that. If you're interested in the transcripts, you can visit me at mathsciencehistory.com. If you're interested in watching the show on YouTube, you can just search for Math Science History with Gabrielle Burchak. And finally, if you're interested in supporting Math Science History, you can donate through my website's coffee button, or you can visit Patreon at patreon.com/mathsciencehistory. All tiers are now pay what you want, starting at $1.39, because 139 is a happy number, which means that when you sum the square of each digit, it eventually reaches the value of 1. Until next time, carpe diem.